Alright, so we're in section 13.2, and we're talking about frequency tables. And distributions. So I want to define our terms first. Our big question today is, how do we find probability if we just have a list of numbers? So we're given a list of numbers that tell us about something. How do we use that to find probability? So let's define some terms. Our frequency table. Sounds very fancy. A frequency table is just a chart that lists how many times a certain thing happens. Or occurs. An example would be a list that said freshmen, sophomores, juniors, seniors, and told how many freshmen we have, how many sophomores we have, how many juniors we have, how many seniors we have. That would be a frequency table. There's a special name for that kind of list. The relative frequency is the probability of one category. So if we had our frequency table that showed freshmen, sophomore, junior, seniors, we could use those numbers to figure out what would be the probability, what percent of the school is sophomores. And then probability distribution again, sounds like a big, intimidating word. Probability distribution just means a list of the probability of all categories. So if the example we've been talking about, we'd have the probability of someone being a freshman, probability of someone being a sophomore, probability of being a junior, probability of being a senior. That would be our probability distribution. So that's all there is to this. We'll do a couple of examples of frequency tables. Probabilities are really easy to get from frequency tables. So are we good with our definitions? Okay, let's look at an example. So this is a list of how many people participate in different sports at school. And we're going to list them out. Sport and number of people. So sport is our category, and then we'll put the number of people over in this other column. So soccer. This is a small school. Only 29 people play soccer. Cross country. Cross country, we have 18 people. Football, 35. And lacrosse, 22. So this is a frequency table. It shows how frequently these things happen at this school by how many people do it. So we're going to calculate some probabilities. So using these numbers, how would we find, if we're thinking of probability being favorable over total, how are we going to find the total? Add all the numbers together. That's all we have to do. We call that the total frequency. That word total is our cue. Total means add everything together. Total frequency, add all together. So we have 29 plus 18 plus 35 plus 22. When I add those together, I get 104. So there are a total of 104 people participating in these sports at this school. And if the problem asks us to find relative frequency of lacrosse, what's going to be our favorable number? Favorable is the thing that we're interested in? 22. 22. It's that easy. Pick that number out. 22 over the total. 22 over 104. There's our relative frequency. That's the probability that someone at this school plays lacrosse. Turn that into a decimal, and this is about 0.21. And as a percentage, how do we turn that into a percent? 2 to the right. So what percent is this? 21%. So the relative frequency of lacrosse players at this school is 21%, or 0.21, or 22 out of 104. And if we wanted the relative frequency of any of the others, pick this number out. If we wanted cross country, that would be the top, that would be the favorable. The total is always 104. That's all there is to it. Now, are we talking about experimental or theoretical probability here? Experimental, why do you say that, Tom? Are we using some kind of mathematical formula to figure out how many people are playing? Or did we count them? We counted them. So we're actually doing, it's like taking something out of the box and counting it. So we're doing an experiment. By counting these people, we're doing an experiment. We're talking about experimental probability. Questions there? So our total frequency, we add everything together. The book will ask you about total frequency. Relative frequency, probability of one category, and we'll do a probability distribution for our next example. Are we good on this example? All right, let's do a probability distribution. So this is for a baseball player. And we're counting what happens when this baseball player goes to bat. Don't worry if you don't know what these different things mean. All that matters is we're counting these numbers. A baseball player has 33 hits. $12 walks. 22 ground outs. 21 strikeouts, and 27 flyouts. Doesn't matter if you know what these things mean in baseball. All that matters is we're counting these things that happen when this baseball player goes up to bat. We want a probability distribution. So let's make a frequency table. So here is our category. This is what happens, and this is the number in the category. So I'm going to call this category hit, and we have 33, a walk, 12. I'm going to call this GO for ground out, 22, SO for strikeout, 21, and FO for flyout, 27. The total, I just add together. I'm just adding all of these, so 33 plus 12 plus 22 plus 21 plus 27. And when I add all those together, I get 115. Probability distribution is just the probability of each category. So what's the probability of a hit if this is the total? 33 over 115. What's the probability of a walk? 12 over 115. Ground out? 22 over 115. Strikeout? 21 over 115. And fly out? 27 over 115. That's our probability distribution. Anybody have their calculator out and can tell me what these are as percentages? Okay. And are you rounding up to the whole number?
Yeah.
Okay. And what happens when you add all of those together? 100%. When you add all the relative frequencies together, you have to get 100%. Because this is asking us, what are the chances that any of these happened when he was at bat? Well, the chance of any of them happening is 100%. So when you that's a way you can check your work if you make a probability distribution, is that all your probabilities have to add to 100%. So what we did in red here is our probability distribution. And that's all there is. Take the category, the number in the category, put it on the top of the fraction, put the total of all of them on the bottom of the fraction, and you have your probability. And that's all there is to frequency tables. Pretty easy, right? I think this is easier than what we did yesterday. Because they give you all the numbers. You don't have to figure anything out. There are all the numbers. Just add them together to get your total. All right. Let me put the homework up on the board, and then I'll pass your folders back. We'll go over the answers to the homework from last time, and then we have some time to work. Page. And tonight's homework, page 833, number 8 through 14 even, and then 15 through 22.